still need to get it typed up here. Oh yeah, you already wrote this, but for anyone who didn't write it, $. $76 to $80. I mean, from 76 to problem 80. Well, if this, sure, I'll make this $. You owe me money.
No, you owe us money.
No, because then you would get -$4, and -4 means you owe somebody. So we'll leave this as is, unless you want to pay me $4.
Actually, it would be the opposite of that because it did that.
Yeah, there's a dash. All right, so we. So are we going to be able to choose who we sit with or not? It's not necessarily going well right yet. We want to start building some images. Now, if you are very anti-tiles, you don't have to. I have some people that for some reason are arguing. But A, we build with tiles. B, we don't. We have just the expressions. Work with your groups to figure out which is greater here, left or right. Do not write on the expression mat that you have, please. That is for use with physical tiles on it, so please don't write on that. And then we're going to compare this expression algebraically without the looking at tiles. We'll just do it algebraically just with math. If you get those done, you can go ahead and start reading 73 to work on it, but you can't just dive in. Okay, you got to read it because it's going to be different. So try 72, then we'll come together for 73. Or we'll come together to check this in a second.
Wait, get the little monkey because I want to say something. 7 plus 4.
I wouldn't necessarily want to use the physical tiles, but I like visual. I mean, sure, but you'll eventually make mistakes. Sure, you can do it mentally, but you'll eventually make some mistakes. I mean, so you can. There's no issue. I'm not setting you up in a trap. I'm just telling you what to expect. Eventually, you'll make mistakes. Because I love mental math. So you have to be comfortable with occasionally I'm going to get a wrong answer. Yes. Yeah. I'm sorry. Could not stop that. Nice. Well, we're starting new math journals for the new year, so to give you expectation, when we start in January, we've eased you into journal keeping and everything else. Our new math journals will have a table of contents at the front. We will be numbering pages, and we will be very careful with our organization to make your life easy. And because I'm tired of grading notebooks, that's flip 10 pages here, flip 17 pages back, and we're all over the place. So trust me, it will benefit you when you're in high school and college, and you have to walk into a class and the person just talks, and then you're expected to take an exam on that. Yeah. And you want to have a good organization system to be able to study. Hey, you're stepping on a book.
Oh, I know.
Even if you don't get the homework done, just put the header there and skip. Or if it's out of order, it'll be in the table of contents out of order. I'd care that the homework is able to be turned into practice work, is able to be turned into challenge. Mm-hmm. I know what you mean, but sometimes it'll be nicer to have in one notebook, like depending on what class you're in and everything.
Good afternoon. Caleb Smith, please come to the office. Caleb Smith, please come to the office. Thank you.
If you want it to be oriented correctly. Now the reason it makes a grid is it then does a quick calculation to average the points and make your lines like line up how it projects the screen and how it senses your touch. So if you only did like 3 points, it wouldn't be very accurate because you triangle. So if you do 4 would be the minimum to make lines vertical and horizontal. You can do that up to 36 points. You could do like 6 lines, 6 down, 6 up. So you could do 11 points, and then it'd be super accurate. Because I don't want to tap at 36. That was 12-point orientation.
Wow.
You just got 6, like just 6. Okay, for left side or right side? All right, so on A, we've got the physical tiles, right? Anyone want to tell me what you got for A and kind of how, Amina?
I got the right is greater.
Okay, what are the values though?
Oh, so the right is 0 and the left is -3.
Remember that the empties are negative, so these could pair. These could pair. And actually, the same values on opposite sides of the mat can pair. These are our 0 pairs, remember? So Mina ended up with 3 negatives left on the top, the what it is side. And the right, then, we could either move or we could pair on opposite sides of the mat, and we get 0. Very good. Now, B. B's a bit tougher. Clear some of this. It wasn't random circles. Annie, what do you think? What do I do? Don't jump me straight to the answer. What do I do here?
Okay, so in the first one, in the first equation, you have to distribute the opposite, like, so 1 becomes -1 and -2x becomes 2x. And
So I get x plus 1. You said that becomes -1 and that becomes positive 2x.
yeah.
Okay.
And then you have to combine like terms. So you would combine the x and the 2x
Okay.
and the 1 and the negative.
Well, what do we get? X and 2x.
Oh, 3x. But the 1 and the negative 1 just like 0.
Positive 1, -1. So that's nothing.
And then on the other side, you distributed the opposite, so it would be 3x. That. And then
Okay.
you combine like terms again, so 3 and -1 and 4.
So I'm going to go ahead and highlight this because that's kind of weird. So 3, the -1, and the positive 4. What's that give you? 6. Good math. And
The x and the negative x cancel each other out.
some fighting x's.
And
How
then
come?
you can't solve which one's greater because it depends on what x is. Yep.
So this would be like saying you won a prize. You got a choice. Well, here I have $6. Crisp $6 bill. Don't trust anybody that tells you they have a crisp $6 bill. Over here, I have 3 envelopes that all have cash in them. You don't know how much, but it could be more than 6. Which do you want? And we don't know, right? You don't know what X is. But what if then? Yeah, what are the envelopes worth? Are they gold envelopes? Okay, hold up. What if X is 5? Or what if X is 7, or 12, or 100, or 1,000? Well, that's going to change things a lot, right? Especially when we compare to 6. So try this out. But now, what's it, by the way, have we talked about what the mathematical word is when we plug something in for something else? We have a couple of these in the building today because we have 6 teachers. Substitute. So when somebody fills in for somebody else, substitute, right? That we do that mathematically.
So what would be called a substitute?
Yeah, it's just substitution is the mathematical thing. So check out our expression mats. You don't have to build this if you don't want to. Which is greater? Okay, we don't know. Now hold on. What if I tell you left is smaller? What could you then tell me? Annie, thank you for raising your hand.
The x is equal to or less than 4. It's less than.
I could just write that. Because couldn't x be like 4.9 and still be less than 5?
Yeah.
And if I tell you left side is less than right side, isn't this just what I just told you? Left side is x is less than right side. So if we just write it like literal, left side is less than right side. And what if I tell you differently? What if I say left side's bigger? So what if I tell you they're equal? Then x has to be 5. So what if I tell you that they're equal, but it doesn't start as easy as this? Like, say, that. If you want, our expression mat page works this way. Left side, what it is, the opposite of what it is. Right side, what it is, the opposite of what it is. These lines in the middle are representing that they're equal. So solve for what x has to be if these are equal.
Okay, so is
Yes.
start
Yeah.
positive or negative?
Not on the equation mix. We're going to use these. Yeah, do you want to do it or no? You hit the card? Where? No.
Oh, you're doing this?
You're
I don't know anyone then what?
So not
Were they turning the corners?
They were from the street across from me, just turning right.
Like out there, like the stop.
She was going slow because someone's in her. So I like went like this, and my backpack, because I had 2 sweatshirts and my binder, saved me from getting. I meant to do it the wrong way, but.
Do you guys have any extra ones?
If you sweatshirts, don't forget them.
No.
And we can play.
I'm going to bring all the binders. You know what you say binder.
I'm gonna say binder kept Tyler a lot. Yeah, that's why.
That's why I
Luckily, I get to cheat. But I don't have to get them all out. It's done for me because I make the big bucks. It's always a joke.
And we don't.
So if I slide across the line, what do I have to do? Flip it,
You have to boop it.
boop it, and boop it. Okay.
He accepted. Embrace the boop.
Oh wait. Ah, I can do multiple.
Holy crap.
Learning things every day. So as I bring these over, I'm gonna have to flip both of these,
You have to boop them.
and that'll pair then. What was it? This. It was a negative x and a positive one, but when I slide it over, it becomes a positive x and a negative one. Because it was a negative x and a positive one, and the opposite of that, positive x, negative one. So these pair to make 0. And then how many constants do I have left unpaired over here? 4. So now I'm writing on the mat, but this has nothing to do with the mat. I'm just using my board. My left side is 3x plus negative 2 or minus 2 if we simplify, equal to x plus 4. Now remember when we talked about like if this was a balanced scale? Has anyone ever seen Monty Python and the Quest for Holy Grail? Please, if somebody watches the clock, stop us at 10:30 or encourage us to stop at 10:30. I have a clip about a balance scale that is, well, my sense of humor funny is some of you probably won't get it, but where they're trying to rationalize whether they can prove a woman is a witch.
Oh,
So this is back from the witch hunt days. So if I have like an amount of weight on one side, like gold, right? Like back in the old days, they would literally weigh gold against items, and there'd be certain trade, right? Or silver or whatever else. And they're equal. And I said, well, I don't want to give you this much gold. I'm going to take some of my gold away. And I'd say I have rice on this side. What would I have to do to keep the scale from getting all lopsided? Okay?
If you have to, what you do to one side, you have to do to the other.
Yeah, so if I'm talking about weight I remove from one side, I have to remove from the other. If I'm talking about numbers or variables, same rules apply. So I could physically remove from my my mat, right? Take things off the mat. Easy? So please, with me, have this written down, and we're gonna write. This would be great for a red pen, actually. Some kind of notification that you're modifying both sides. We're gonna take an x off the mat from both sides of it. Then we end up, we got to rewrite what we now have.
Wait, how'd you get 2x for?
Because I took an x away.
For each side.
Remember, they're physical tiles. Think about we have 3 x tiles. I take away 1 x tile. You don't take the x off of the 3. You remove a tile, right? Oliver, what do I do now?
I know what x means. So, you take 4 because it's 2x minus 2. So you add 2 to the 4.
No. Yes, but we say it differently. Annie, you've been like
Wait,
reaching through the roof.
I might have done this wrong. But I took away, I added negative 2 to each side.
Hold on a sec. I can't scroll. So I remove x, right? Off the mat. That's what I did, right? These are technically 0, so they're gone. These are technically 0, so they're gone. We are trying to isolate x. Sorry, continue.
Okay, so, oh my god, I'm stuck in a loop, like Miss Becker. So you want to get the variable alone on one side of the equal sign. So I added 2 to negative 2 to make 0, but then you have to do, when you do one thing to one side, you have to do it to the other side. So then you would add 2 to 4, which is going to be 6, and then you would do 2 divided by 6 because it's 2x, and then, well, 6 divided by 2, and then, so x.
No, ooh, you're way. Ooh, hold on, slow down. You're getting far ahead of us.
Sorry.
Because I'm still trying to process the first thing that you said. So those of us in here that aren't totally seeing this, and I feel bad for telling Oliver no because technically he's right, but what we need to do is chill. What we need to do is get rid of these, right? We need to get these off the mat. We need to start to get x by itself. Or I should get rid of this. Now, can I get rid of an x over here? No, crap. I need to take away 2 negatives. Can I take away 2 negatives over here? No. What could I say? It. 0 pairs. I don't want to pull up the tile menu. But if I did a -1 and a +1, -1 and a +1, now I could take away the 2 negatives, which is just like adding 2, and I do it to both sides. So what we're going to write, I need you to understand though, what we're doing is getting rid of the -2. But to do that, algebraically, we write it as add 2, add 2. So please have that in your notes. Then the 2x is gone because these became zeros. And if I physically do it, how long is this going to take? Drag. Those are zeros. Drag. Okay. 2x is now sitting equal to 6. Now, again, we want the x by itself, right? So let's get rid of these zeros. Drag these down to the abyss. And those ones get to stay there. Alex?
Well, now what you have to do is divide by 2 for both.
Why can't I just take an x away?
Because there's not an x on the right side.
So I say if this quantity is equal to this quantity, if I split it in half, I will split it in half. Well, that's stacked on top of itself.
I figured it out.
What would each x be equal to?
3.
3. And algebraically, we write that divide by 2, divide by 2, and then below that, if I could scroll on this screen, we would write x equals 3. Yes? Yes, but I was making sense of what we're doing. Not everybody gets it as quick. We can check this by starting over. If I put 3 in for the x values or -3 for the negative x's, the left side will equal the right side. It will balance out, and we know it works. If you have time on a test, plug your answers in and check them. So many kids, I've marked things wrong, I set up an equation or something, as soon as they look at it, they're like, oh, that doesn't make sense. Why couldn't you do that on your own? Oh, I can, I just didn't. I can't help you get a mastery if you're not willing to. Okay, so let's try this again. You guys on your own set up this equation. You don't have to do it physically. You can just do it algebraically. I know it tells you do the tiles, but we're accelerated, so let's just try to do it mathematically. You don't have to, and we're going to work quickly. So I would prefer you not to on this one. What? It's I'm going to write it here, too.
No, I'm dying.
You're okay. You're okay. So, okay, again, off-topic talk, but we can do this because you guys can get back on task. Jerry Seinfeld, well, a lot of you probably know who he is. He has a new special out on Netflix. He's a stand-up comedian, and so the whole you're okay. One of my previous students, she's like, all because you tell me I'm okay doesn't make me okay. They got very upset at me. Jerry Seinfeld has this bit where he's like, every time I go over to visit my parents, my dad always wants to move things. It's like he saves it for me, right? Like, oh, come help me move this bed, move this dresser. never fail when we're moving. He's always like, easy, 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 easy. And he was dad, they're like, easy, easy. No, it's not easy. So Seinfeld started, he's like, he should be saying difficult, 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 difficult. You guys haven't moved a lot of stuff. Come see me once you've moved multiple people. Yeah, pick up beds, dressers, all that stuff. Who knows what X is here yet? Yeah, because Amy can actually ignore me when I tell weird stories. Yeah, Bouvendier too. Bouvendier, we haven't talked yet today. What'd you do to solve this?
Okay, so I didn't add 5 yet because I still needed to add the simple term.
Yeah, you needed to simplify. So, Boob decided to do this first.
And then I got 1.
One what?
5x.
Ah, 5x plus 1.
And then I got 2x.
At this point, you have 4 choices. And they're all right. Now, there's also wrong choices. But Bouvendier has 4 different options of what he can do right now. What'd you choose? You don't need to know all 4 of those right now. You need a graphing calculator, Steven?
Yeah.
Right here. Whatever you want. How many?
Like 5 plus like 2.
Well, I have 4 of the black one, choose the 4th one. And then I thought we had plenty of calculators in the school. Apparently not. So you added 5. Dealing with the constants first is nice. Either way, we got a group like terms. So I either would have to subtract 1 to bring it over here, or add 5 to bring it over here. This gets awkward, but it out. So this is why we didn't do it with real tiles. We could do this with real tiles. We'd be flipping and everything else, but just trust the math. What do you want to do now?
So I want to take away 2x.
No, you don't, because then there'd be nothing over
Yeah,
here.
I know, but I would have to first move the 6 onto the other side, which would make it negative.
Okay, you're right. That's totally an option we can take, but you're making more work for yourself. Easiest thing to do here, and it's not like simplest, but we'll understand this better and better as we go. Easiest thing to do now that we've grouped our constants, our numbers, is group your variables just by doing whatever to get it off of this side. How do I get rid of these? Minus 5x. So minus 5x. Now that, awkwardly enough, leaves you with, I hope people are paying attention. I see some people spacing out and like writing notes and stuff. This is where this gets weird. The opposite of 3x tiles is now 6. The opposite of 3x tiles. So, if we're trying to think through this, I don't like the opposite of things I don't know. That's 2 things I don't really like. Things I don't know and opposites. So, I could first say, well, I don't like this being opposite, so let's make this the opposite. And if I make this the opposite of the opposite, this has to do the same. Really, what I would be doing there is multiplying by -1. You could then rewrite this as 3x equals -6 if you wanted to. But I can do that and get rid of the 3 at the same time. What can I do to turn this into a straight up positive x? Oliver? Nope. Close. Try again. Divide by -3. To get rid of the -3, which is multiplying, we divide by the -3. There are 4 correct ways to do this. I'm going to run through a couple more here, but I'm going to go fast. Okay, do you have the same answer?
Yeah.
Okay.
No.
Then you made a mistake somewhere. We'll find your mistake. This is just what we were just talking about. So let's run another way. I really don't like negative variables. Sorry, I see some people still writing. So when I...
Oh my god.
Hey, people in the back, you gotta watch out for kicking stuff towards the people in the front. Yeah, I about took out Ian. Really? Hey, just leave that stool in front. We don't need stools sitting up in there. Just put them in the front or the back. Don't put them up on there. They don't look broke even. Alright, so here's my strategy. The Hudson way to solve equations that are complicated on both sides. 2x minus 5, negative 5. Well, after we simplified, we had 5x and 1, right? So everybody should be starting here.
I did.
You did or did not?
Oh, is
Did
this
not.
a new question?
Did you not? Oh, did you go ahead and start moving constants at the beginning?
Yeah.
I did not combine. I just subtracted 2x.
So we always need to combine like terms on the sides first before we start moving stuff. Hey, so we need to be listening because we're finding the issues that we don't find until we start playing with this stuff. You could actually get the same answer, and you did, but to make the math easier, we combining the like terms that we can. So that's why, even though on this side to start, it was -1 plus 5x plus 2, we gotta combine these to start. We don't technically have to, but mathematically we do. Like, not that we have to, but we should. It's the right way to do it. So we get this. Then, because I want variables to be positive, this is a me thing, not general, like mathematically right. This is a me thing. I look for the bigger variable. And I say this side gets to be my variable side, because he's bigger. So I take away the 2x to make this side my variable side. Now what happens is I get 3x positive as my variable.
Oh, it's -5, not 5. I see what I did now.
There we go. Then I can move my constant over. So how?
Negative -1.
-1 from both sides. Now I get 3x equals -6. Remember that thing I wrote in red over here? The opposite of the opposite. Huh? And we divide by 3 and get x is equal to -2. There are two other ways to do this, just moving things in different orders. Because when we start here, give me your eyes for a second. Here's my options. Take away the 2x from both sides. Add 5 to both sides. Take away the 5x from both sides. Take away a 1 from both sides. So you can't divide to start, because then you're going to be cutting other values. Like it. Okay, we could, but then we literally have to cut everything. So let's say we wanted to start by dividing by 2. We'd have to divide by 2, divide by 2, divide by 2, divide by, and it just gets messy, so we don't. Yeah, move all the terms together before we ever do any multiplication or division. Try this on 75. See how many of those you can get through in 5 minutes. Check for accuracy. Take this seriously, guys. I know some of you are kind of in and out in class, and you're like paying attention or writing or not. Take this part seriously. You really got to try these out.
Julia Foggiano, please come to the office. Julia Foggiano, please come to the office. Thank you.
Foggiano, it's Italian. It's sweet.
I thought that. No, Foggiano.
Foggiano, F-A-L.
It's Foggiano. Wow.
Yeah.
The name.
Talk to people at your table. Don't ask me first.
Mitchell. I'll play your Mitchell.
Okay. Is he still going to help you?
I got you say like the names, your last name, blah blah. It's just the name Sunday.
Yeah.
If I had last name was Smith, it would work. The name Smith, Simon Smith. But it's his last name is Scott. All those times you show us that beautiful flip.
Good morning, Marcy. I am actually still teaching right now. Could I get you to call back in 10 minutes? Thank you very much. What do you mean combined zero pairs? They're zero. That's not a zero pair. 2x take away 1x will leave you with 1x. You mean the fact that we have 1x on both sides? Oh, yeah. Yeah, you can break up the 2x into x plus x. Yeah. Hey, so Izzy has an interesting way of looking at this. She's thinking of this as, well, I see an x being taken away. If I think of this split up as x plus x, it's easy to see that the 1x minus x will be 0, and we still have one of the x's there. So that's another way to look at that. I know you guys are really close friends, but I would like to be able to have you guys work together. I don't care if you guys are doing work. You haven't tried any of these equations. And I literally just asked you, please take this seriously. We need to practice this association. That's like just giving you more. Like, I don't care what you said. I'm going to sit back here and tear a paper up. You don't want to be in this class. I'm going to transfer it out. Yo. House Rules. I don't know. I mean, it's a really good song. I just don't pay for ringtones. That was just a free one. What? Yes. It's. Notice my screen is frozen.
I thought I recognized that.
As you pack up your algebra tiles, please make sure that the pamphlet is in there. If it's not, check on the floor. Please make sure that any tiles around your desk get picked up. Even if you haven't gotten to the answer, please write these down. These are the answers. 275. Please write them down, even if you're not done solving them. They're good practice. A is 3, B is 6, C is 2, D is 4, E is 2, and F can't be solved. And we'll look at more stuff like that tomorrow. But F can't be solved. Now, talking about balance scales. Half of this is probably just going to confuse the crap out of you. Oh, I can't. I got to stop.